Welcome to our journey through the cosmos, where we'll explore Jupiter, the largest planet in our solar system. Often referred to as the king of the planets, Jupiter is a gas giant that has fascinated astronomers and scientists for centuries. With its swirling clouds, majestic storms, and dozens of moons, Jupiter is a world unlike any other. Join us as we uncover its secrets and understand its significance in the grand tapestry of our solar system. As we delve deeper into Jupiter's mysteries, we'll explore its atmosphere, its complex system of moons, and the role it plays in shaping the solar system as we know it. Jupiter is a colossal planet, more than 11 times the diameter of Earth and over 300 times its mass. Its immense size means that it has a gravitational pull strong enough to influence the orbits of other celestial bodies. Jupiter is primarily composed of hydrogen and helium, with its atmosphere marked by colorful bands of clouds and powerful storms. These bands result from high-speed winds and different temperatures at various altitudes, creating a striking and dynamic appearance. The atmospheric conditions on Jupiter are incredibly complex, with storms and winds reaching speeds of up to 400 miles per hour. The intricate patterns we observe are a result of various processes, including convection and rotation. Jupiter's rapid rotation, completing a full turn approximately every 10 hours, contributes to the extreme weather and vibrant colors of its clouds. One of Jupiter's most iconic features is the Great Red Spot, a massive storm that has been raging for at least 350 years. This enormous anticyclone is so large that 3 Earths could fit inside it. The storm's reddish hue remains a subject of scientific inquiry, with researchers exploring the chemical reactions and atmospheric conditions that create its striking color. The Great Red Spot is not a static feature. It has been observed to change in size and color over time. Studies suggest that variations in temperature and composition within the storm contribute to these changes, prompting scientists to investigate the underlying dynamics of such a long-lived weather system. The Great Red Spot is a remarkable example of the dynamic weather patterns on Jupiter. Its longevity and size challenge our understanding of atmospheric processes. Unlike storms on Earth, which eventually dissipate, the Great Red Spot has persisted for centuries, showcasing the complexity and power of Jupiter's atmosphere. By studying this storm, we gain insights into the behavior of similar storms in our own atmosphere, furthering our understanding of planetary meteorology. Jupiter is not just about its massive size. It also boasts an impressive collection of moons, over 79 confirmed. Among them are 4 large moons known as the Galilean moons: Io, Europa, Ganymede, and Callisto. These moons were discovered by Galileo Galilei in 1610, and they offer a fascinating glimpse into the diversity of celestial bodies. Each of these moons presents a unique environment and geological history, contributing to our understanding of not only Jupiter, but also the broader processes of planetary formation. Io, the most geologically active body in the solar system, is characterized by its many volcanoes and sulfuric surface. The intense gravitational tug from Jupiter and its other moons creates tidal forces that heat Io's interior, leading to its dramatic volcanic activity. This makes Io a unique laboratory for studying geological processes. The sheer number of volcanoes, over 400, along with the variety of materials ejected from its surface, gives scientists a unique opportunity to study how internal heat drives geological change. Next is Europa, a moon covered in a thick layer of ice. Beneath its surface lies a vast ocean of liquid water, making it one of the most promising places to search for extraterrestrial life. Scientists believe that Europa's subsurface ocean could harbor the necessary conditions for life, prompting exciting missions to explore its potential. The ice crust of Europa is believed to be around 15 to 25 kilometers thick, and researchers speculate that the ocean below could be in contact with the moon's rocky mantle, creating a potentially habitable environment. The upcoming Europa Clipper mission aims to investigate this ocean and its potential for life. Europa's icy surface and subsurface ocean make it a prime candidate for astrobiological studies. Future missions, such as NASA's Europa Clipper, aim to investigate its ice shell and assess its habitability. If life exists there, it could provide insights into the possibilities of life beyond Earth. We are particularly interested in the chemistry of Europa's ocean, which may be enriched with salts and other compounds that could support life. By analyzing the surface and searching for plumes of water vapor, we can gather critical data about its potential for hosting life. Ganymede, the largest moon in the solar system, is unique not only for its size, but also for being the only moon known to have its own magnetic field. Its surface features a mix of two types of terrain: bright, icy regions, and darker, heavily cratered areas. This diversity offers clues about the moon's geological history. Ganymede's magnetic field suggests that it has a partially liquid iron or iron sulfide core, making it geologically active. Its complex geology tells a story of processes that have shaped its surface over billions of years. Callisto, heavily cratered and ancient, provides a different perspective. It has a very thin atmosphere and is considered one of the most heavily cratered bodies in the solar system. Its surface tells the story of a relatively quiet geological past, offering a stark contrast to the active worlds of Io and Europa. Callisto's surface is a testament to the bombardment it has experienced throughout its history, with craters that reveal insights into the history of our solar system. Scientists are particularly interested in understanding its subsurface, which may harbor a liquid ocean as well. Jupiter's magnetic field is the strongest of any planet in our solar system, extending millions of kilometers into space. This powerful magnetosphere protects its moons and is responsible for the stunning auroras that dance at its poles. These auroras are created by charged particles from the solar wind interacting with Jupiter's magnetic field, resulting in breathtaking displays of light. The auroras on Jupiter are much more intense than those on Earth, and studying them helps scientists understand the complex interactions between the solar wind and a planet's magnetic field. Observations from missions like Juno have provided invaluable data on these phenomena. Jupiter's magnetosphere and its interactions with its moons present exciting opportunities for future exploration. Understanding the dynamics of this giant planet can enhance our knowledge of planetary systems, including exoplanets around other stars. Missions like Juno have already provided invaluable data about Jupiter's atmosphere, interior structure, and magnetic field. The data from Juno's flybys have revolutionized our understanding of Jupiter's composition and its internal structure, revealing insights into its atmospheric dynamics and helping to unravel the mysteries of gas giants. Jupiter has also played a crucial role in our understanding of the solar system's formation. As a gas giant, it likely formed early in the solar system's history and influenced the development of other planets through its massive gravitational pull. Its presence may have helped shield the inner planets from frequent impacts by redirecting comets and asteroids. The study of Jupiter's formation and evolution provides critical insights into how planetary systems develop. By understanding Jupiter's role in shaping the orbits and characteristics of other celestial bodies, we can piece together the complex history of our solar system. Studying Jupiter not only sheds light on its own mysteries, but also provides insights into planetary formation and evolution. By understanding gas giants, we can better comprehend the diversity of exoplanets we observe in distant star systems. Jupiter serves as a model for exploring how planetary systems form and evolve over time. With the discovery of thousands of exoplanets, many resembling Jupiter, our studies of this giant planet inform our search for life and habitable conditions elsewhere in the universe. As we marvel at Jupiter, we are reminded of our place in the universe. Its vastness and beauty inspire curiosity and wonder, urging us to explore beyond our own planet. Each discovery about Jupiter deepens our understanding of the cosmos and highlights the interconnectedness of all celestial bodies. Jupiter's legacy continues to inspire new generations of scientists and explorers. Its presence in our night sky serves as a reminder of the mysteries that lie beyond our world and the quest for knowledge that drives us to explore the universe.